Welcome today. I want to welcome you to this lesson. So let us look at this. We are still looking at the titration questions and calculations. This series continues until we ensure that each and every student is comfortable with these questions. That's why we are bringing in different questions and the different approaches with which they are tackled. So let us go ahead and look at this question. You are provided with 1. A monobasic acid HCl solution A. A monobasic base XOH RFM is 40, containing 1 gram of solute dissolved in 250 of distilled water solution B. So that is what you should mark, that 1 gram of this monobasic base was dissolved, 1 gram was dissolved to form or to make 250 centimeters cube. So 1 gram, this is 1 gram per 250 centimeters cube. This is the mass in 250. So in case you want per liter, you know what to do. So you will ask, if 1 gram is in 250, what about 1,000 centimeters cube? So this is 1 gram in 250. Solution C, containing 28.6 grams of sodium carbonate and water, dissolved in 1 liter of water. So here it means that 28.6 grams was dissolved to form 1 liter. Therefore, this is the mass. This is the mass in grams per liter. Therefore, 28.6. It is the mass in grams per liter of solution C. So what are you required to do? You are required to standardize solution BA with solution B, and then determine the number of moles of water of crystallization in the formula, in this formula. So let us look at the procedure. Pipette 25 of solution B into a 250 centimeters cube conical flask. Add 2 to 3 drops of methyl orange indicator. Fill the puree with solution A and titrate with solution B. Repeat the procedure twice to attain a concordant results. Enter your results in the table below. So I'm going to give you the values. So our values today, we are going to use 12.4, 12.5, and then 12.6. So our initial we will take to be 0, 0.0, 0.0, and our difference here, arithmetic difference, is going to be 12.4, 12.5, 12.6. So our average, we go ahead and calculate out the average. Average, that is 12.5 plus 12.4 plus 12.6, and then we divide by everything by 3. This one is going to add 1 here, so the average is 12.5 centimeters cube. 12.5 centimeters cube, that is our average. Okay, so let us see the next question. Calculate the number of moles of solution B. Remember, you need to understand the procedure itself first. Solution B is reacting with solution A. And what is solution B? Solution B is a base, which is could be sodium carbonate, sodium hydroxide, magnesium. We don't know, but it is a monobasic, so it could be potassium hydroxide. But since RFM is 40, we can guess, but we don't want to guess. Therefore, we know it is a base plus an acid HCl. So we should know that. So B, we can get the number of moles of B from this information. So we have 1 gram dissolved in 250. That one is easier because we have RFM, we have mass. Number of moles is simple. So let us go back. You remember this triangle here. Moles or mass, RFM, mass. No, we have mass, moles, sorry, moles. So how do you get moles? Moles is equal mass over RFM. So moles, because we are asked to calculate moles of B, and B we see. We know B, it was 1 gram, 1 gram, where is it? 1 gram. 1 gram dissolved in 250, but the RFM is here, so we can get the number of moles in 250. Number of moles in 250 is simple. So moles equal to mass over RFM. Our mass is 1 divided by RFM, which is 40, which will give us 0.025 moles. 0.025 moles. That is the moles of solution B in 250. Very good. That's one way you can do it. There is another way you can do it, but I don't want to go for that long way. That is the simple way and the easier one. So calculate the number of moles of solution A used. Solution A used. Calculate the number of moles of solution A used. So let us go back and see what was solution A. Solution A is a monobasic acid solution A. So solution A has reacted with B, and we know the number of moles of B in 250. So that one is easier. So let us see. Remember these moles. Ukumbuke kwamba hizi moles tuko nazo hapa ni za nini? Ni sa solution B, lakini volume ya solution B ilikuwa 250 cm3. Lakini B tumetumia B kiasi gani? B we just pipette 25 of solution B into. So solution B reacted with A. 25 cm3 of solution, 25 cm3 of solution B reacted with 12 cm3 solution A. Sasa hatuwezi tumia moles za solution B zikiwa zote kwa 250. No, we just find now, we want to know if 250 of solution B has these moles, what will be 25 of solution B contain? What will be the number of moles in 25 cm3 of solution B? Yes. So let us look at this. Why is it changing the color? Oh. Okay. So we say 250 cm3 solution B contains 0.025 moles. 25 cm3, the one that reacted with A, B, will contain what? So it is 25 times this divided by this, which will give us 0.0025 moles. Yes. Now we know the number of moles of A. Automatically we are going to know the number of moles of B. Automatically now we know the number of moles of B that reacted with A. So we use the ratio because both of them are monobasic, therefore the ratio, mole ratio is 1:1, meaning that moles of B in 25 cm3 solution B, moles of 25 cm3 solution B will be equal to moles of 12.5 cm3 solution A. Okay, they have said that moles of 25 centimeters cube solution B will be equal to 10 moles of 12.5 centimeters cube solution A, because the ratio is 1 to 5. So moles of A is equal to 0.0025 moles. Why? The ratio is 1 to 1. This is a monobasic and a monobasic base, a monobasic acid. Therefore, they are going to, it's like sodium hydroxide plus HCl. The ratio is 1 to 1. So the moles is like that. So let us go ahead and finish the part D. Calculate the concentration of solution A in moles per liter. In moles per liter. So concentration of a solution A in moles per liter simply means molarity. We are calculating molarity. Molarity is the number of moles in 1 liter. So we are going to ask that solution A, 12.5 centimeters cube, contain these moles, 0.0025. So we will ask 1,000 centimeters cube, which is the liter, will contain what? So it is times C divided by this, and it's going to give you 0.2 capital M. That is the molarity of solution A. Number of moles in a liter. We have finished, so we go to procedure 2. Procedure 2. Pipette 25 centimeters cube of solution C into a conical flask. Add 2 to 3 drops of methyl orange indicator. Fill the puree with solution A and titrate with solution C. So solution C, we are going to put it in a conical flask 25. So C need 25. And then the conical, whatever we are going to have from the puree is solution A. But we know a lot of information about solution A. First, we know the concentration, we know the molarity of solution A, the one we have just calculated here. So we know the molarity of A. Molarity of A, we know it is 0.2 capital M molarity. So it is simple. This one is going to be very simple because you need to connect. You need to connect from part A, procedure 2, procedure 2. So you have to connect. So here I'm going to give you the procedure or the volume. The volume is 24.9, 25.0 and 25.1. 0.0, 0.0, 0.0. So let us do our mathematics here. Initial is that, and then this is 24.9, this is 25.0, and this is 25.1. Our average is 24.9 plus 25.0 plus 25.1 divided by 3, which is going to give us 25.0 centimeters cube. Calculate the number of moles of solution A used. Number of moles of solution A used. But we know the concentration of solution A. 0.2 capital M solution A implies solution A implies that 0.2 is the number of moles where in 1,000 centimeters cube. So we are going to ask 25 centimeters cube of solution A will contain how many moles? So 25 times 0.2 divided by 1,000 will give us the number of moles that reacted there. So that one will give us 0.005 moles. They have given us the equation. This equation you are supposed to write it yourself, but now thank God they have given us. You can see that the ratio is 1 to 2. The carbonate ratio is 1 and this is 2. So given the equation below, calculate the number of moles of solution C. Remember, solution C is the carbonate, sodium carbonate, right? So, but here we have used solution, this is 25 centimeters cube. This one also 25 centimeters cube, but we know the number of moles of this, which is 0.05. We know the number of moles of this, 0.05. 0.005 moles. But the ratio is 1 to 2. So if 2 is equal to this, then what will be this? So moles of sodium carbonate is going to be a half times 0.005, which is going to give us 0.0025 moles. A half of it. Calculate the concentration of solution C in moles per liter. So we want to calculate the molarity of C. Molarity of C. But we know C, we used 25 centimeters cube of C. So this number of moles that we have here, this one is number of moles of solution C in 25 centimeters cube. So what about 1,000? And that is molarity. 25 centimeters cube, solution C equal to 0.0025 moles. 1 liter centimeters cube, 1,000 centimeters cube equal to 1 liter. Solution C will be what? And this one will give you 0.1 capital M. 0.1 capital M. That's what the molarity of solution C is 0.1. Let's go to the next page. So the next question is determine the relative formula mass of C. The relative formula. So we want to calculate the RFM of C. So I want to remind you of this triangle here that says that molarity RFM mass, which must be grams per liter. That mass of whatever we are looking, we must be in grams per liter. But we have mass in grams per liter of solution C. So here, solution C contains this, ndio hii, 28.6 grams per liter. So we know the mass in grams per liter of solution C. Yet again, we have the molarity here. The molarity of solution C is here. We have the molarity of solution C, 0.1. Now using this formula, sorry for that. So we are going to say now that RFM of solution C is equal to mass in grams per liter divided by molarity. Mass in grams per liter is 28.6. Molarity is 0.1, which is going to give us 286 grams. That is the RFM. The RFM of that is 286. Very simple. Determine the number of moles of water of crystallization of C. This, remember, C is sodium 2 carbonate dot N water. So we want to look for this value. But when you add everything in this salt, which is sodium carbonate with some water of crystallization, the answer should be the RFM, which is 286. So what is missing here? They should have given us that sodium equal to 23, oxygen equal to 16, hydrogen equal to 1, sodium or carbon equal to 12. So once we have all that, we can go ahead and do it. So let us calculate this one. So sodium, that is 23 times 2 for sodium, plus carbon, which is 12, plus oxygen, which is 16 times 3, plus N times 18, which will give us 286. This plus this one will give us 106 plus 18N equal to 286. Like terms together, 18N is equal to 286 minus 106. So 18N equal to 180. So divided by 18, and the N is equal to 10. So N is equal to 10, meaning that this formula is sodium 2 carbonate dot 10 water. Thank you. Thank you for your time, and thank you for supporting this channel. May you be blessed a lot. Thank you.